Hi, welcome back to this video in which I will talk about the service discovery mechanisms. By the end of this lecture, we will be able to distinguish between two service discovery mechanisms and use the appropriate one according to your context. Before starting, I have to recall that when adopting synchronous remote procedure invocation between services, we are obliged to deal with the service discovery challenge. The purpose is to find a way to know the network location of a service instance to establish this synchronous communication with that instance. So the presentation is structured as follows. I will illustrate the problem we are trying to solve, then I will propose two different solutions, each relying on different patterns, before providing the most suitable cases to use each of them. We suppose that you are writing some code that invokes a service that has a REST API. In order to make a request, your code needs to know the network location, the IP address, and the port number of a service instance. In a traditional application running on a physical hardware, the network locations of service instances are usually static. For example, your code could read the network locations from a configuration file that is occasionally updated. But in modern cloud-based microservices application, it is usually not that simple. A modern application is much more dynamic. Service instances have dynamically assigned network locations. In addition to that, the set of service instances changes dynamically because of auto-scaling, failures, and upgrades. One could say, what about statically configure a client with the IP addresses of the services? The answer is obviously no, this is not practical. Instead, an application should use a dynamic service discovery mechanism. Service discovery is conceptually quite simple. Its key component is a service registry, which is a database of the network locations of an application service instances. The service discovery mechanism updates the service registry when service instances start and stop. When a client invokes a service, the service discovery mechanism queries the service registry to obtain a list of available service instances, and then routes the request to one of them. To implement a service discovery, there are two main ways. The first option is when the services and their clients interact directly with the service registry. And the second is when deployment infrastructure handles service discovery. So let's zoom in the first option. One way of implementing the service discovery is when the application services and their clients directly interact with the service registry. A service instance registers its network location with the service registry. A service client invokes a service by first querying the service registry to obtain a list of service instances. It then sends a request to one of these instances. This approach to service discovery is a combination of two patterns. The first pattern is the self-registration pattern. Service instance invokes the service registry's registration API to register its network location. It may also supply a health check URL. The health check URL is an API endpoint that the service registry invokes periodically to verify that the service instance is healthy and available to handle requests. A service registry may require a service instance to periodically invoke a healthbeat API in order to prevent its registration from expiring. The second pattern is the client-side discovery pattern. When a service client wants to invoke a service, it queries the service registry to obtain a list of the service's instances. To improve performance, the client might cache the service instances, and the service client then uses a load balancing algorithm such as round robin or random to select a service instance. It then makes a request to select service instance. One benefit of application-level service discovery is that it handles the scenario when services are deployed on multiple deployment platforms. Imagine, for example, you have deployed only some of services on Kubernetes and the rest is running in a legacy on-premise environment. In this case, the application-level service discovery works across both environments. One drawback of application-level service discovery is that you need a service discovery library for every language and possibly framework that you use. Another drawback of application-level service discovery is that you are responsible for setting up and managing the service registry, which is a distraction. As a result, it is usually better to use a service discovery mechanism that is provided by the deployment infrastructure. Many modern deployment platforms such as Docker and Kubernetes have a built-in service registry and service discovery mechanism. So let's see how does it work. The deployments platform gives each service a DNS name, a virtual IP address, and a DNS name that resolves to the virtual IP address. A service client makes a request to the DNS name, and the deployments platform automatically routes the request to one of the available service instances. As a result, service registration, service discovery, and request routing are entirely handled by the deployments platform. The deployments platform includes a service registry that tracks the IP addresses of the deployed services. In this example, a client accesses the service B using the DNS name service B, which resolves to a specific virtual IP address. The deployments platform automatically load balances requests across the three instances of the service B. This approach is a combination of two patterns. The third-party registration pattern, instead of a service registration itself with the service registry, a third party called the registrar, which is typically part of the deployments platform, handles the registration. And the second pattern is the server-side discovery pattern. Instead of a client querying the service registry, it makes a request to a DNS name, which resolves to a request router that queries the service registry and load balances requests. The key benefit of platform-provided service discovery is that all aspects of service discovery are entirely handled by the deployments platform. Neither the services nor the clients contain any service discovery code. Consequently, the service discovery mechanism is readily available to all services and clients, regardless of which language or framework they are written in. One drawback of platform-provided service discovery is that it only supports the discovery of services that have been deployed using the same platform. For example, Kubernetes-based discovery only works for services running on Kubernetes. Despite this limitation, I recommend using platform-provided service discovery wherever possible. To sum up, here are the main ideas you have to keep in mind. An architecture that uses synchronous protocols must include a service discovery mechanism in order for clients to determine the network location of a service instance. The simplest approach is to use the service discovery mechanism implemented by the deployments platform, the server-side discovery, and the third-party registration patterns. But an alternative approach is to implement service discovery at the application level, the client-side discovery and self-registration patterns. It is more work, but it does handle the scenario where services are running on multiple deployments platforms. That said, don't hesitate to ask me questions about this content, and thanks for subscribing and sharing. See you in the next video.